Goal and loop engineering for Claude Code. In the next few minutes, we will go over the best tips and tricks to get you to stop babysitting your AI agent. The status quo often involves constant supervision, as the model works, stops, and waits for manual input like keep going. This makes you the bottleneck in large migrations. The illusion of done occurs when the agent self-reports completion, but leaves half-finished stubs. Enter loop engineering. The old way was prompting the agent turn by turn. The new way is designing the system that prompts the agent. The core principle is to separate the maker from the checker. The model that writes the code should never grade its own homework. We use two engines for autonomy, goal and loop. Goal is condition-driven, running continuously until a verifiable state is met, best for bounded tasks like migrations and refactors. Loop is time-driven, running on a scheduled interval for background tasks like polling PRs or updating docs. With /goal, you define a completion condition, and the agent works autonomously, turn after turn. A separate fast model called Haiku evaluates the conversation transcript after every turn to ensure progress toward the goal. The evaluation loop involves Claude, the maker, editing code and running tests. The transcript goes to Haiku, the evaluator, who checks the output against the original /goal condition. If the condition is met, the loop terminates. The evaluator only grades what the maker prints into the terminal transcript. Writing a good condition requires three components: a measurable end state, constraints that define strict bounds, and an escape hatch to prevent infinite execution. Ensure your end state is provable via terminal output, and always include a stop condition. The /loop command acts as the background heartbeat, transforming the agent into an in-session cron job scheduler. It has strict limitations, including session scoping, a maximum of 50 tasks, auto-expiry after 3 days, and a jitter offset to prevent API stampedes. Choosing the right tool depends on the use case. /goal is great for refactors and test fixing, triggered when the previous turn finishes and stops when the evaluator says yes. /loop is best for reminders and PR polling, triggered by an interval elapsed and manually canceled. We move from prompting to production with examples like the autofixer using /goal and the PR watchdog and the async documenter using /loop. Avoid the vague token burner anti-pattern, where vague goals like make the codebase production ready never finish and burn tokens indefinitely. A key warning is the $200 overnight warning. A tireless evaluator loop won't get tired. If a condition is vague, impossible, or lacks evidence, it will keep running. Defensive fixes include appending a stop condition, checking evaluator reasoning, and never running open-ended creative goals unsupervised overnight. Isolating the chaos with worktrees is essential. Multiple parallel loops can overwrite files and cause merge conflicts. The solution is using isolation worktree, or launching with /worktree, which assigns each loop a separate, clean working directory on its own Git branch. True autonomy requires stacking the primitives, execution with goal or loop, permissions via auto mode to remove human blockers, and context using Claude.md and agent skills for persistent memory. A loop without all three will halt or invent its own rules. Build the loop, stay the engineer. Loop engineering changes the work, but does not delete you from it. Verification is still on you. Done is a claim, not a proof. Your job is to ship code you confirmed works. Thanks for watching this video on loop engineering, made by the Context Window channel.